Okay, today we are going to learn about identifying functions. And some people think that functions are very confusing, so I'm going to do my best to try to explain what a function is. First of all, we have to talk about a relation. A relation is really just a set of points, and we've done a lot of different graphs before, so just imagine any set of points that you have. There's some kind of relationship between those points. But a function is special. A function is a rule that will assign each input to exactly one output. So to give you some examples of what this might look like, you could think of something as simple as a machine. And some people say like a toaster is a good example of a function. I didn't find an image of a toaster, but in this example, we kind of have these apples going into this machine, and what's coming out of this machine or this function is that the apples get sliced up. Sometimes you see an image like this drawn for a function machine, and the input is sometimes called the domain. It's really your x values. And what happens to this domain or this input is something happens to it, and you have this range or this output or y values that come out. And then if we look at a more mathematical example, if I have this function right here, my y values are going to equal my x values cubed. We can input a bunch of values. So let's just say we're inputting the 0. If 0 goes in this formula, 0 cubed is 0. So 0 would be my output that goes along with my input of 0. However, when you input 1, 1 cubed happens to be 1. But here's the example where it starts to really change. When 2 is inputted to this formula, 2 to the third power means 2 times 2 times 2. Your output is 8. And of course, 3 could be input. 3 times 3 times 3 is 27. And we could put in whatever numbers we wanted to. We could put in negatives, we could put in decimals, we could put in fractions. So this is a little more of like a pure mathematical example of a function. And these are just kind of examples to get your brain wrapped around the idea that when you plug something in to a function, you have different outputs or values that you get. Sometimes you'll see an example like this drawn for functions. This is an example of a function because each of these x values that aren't really labeled are matching one y value or output value over here. And again, this one maps to this one maps to this. Each one of these inputs has exactly one output. And it's okay that both of these inputs go to the same y value. What you can't have with a function, and there's a good example down here, is that these map onto one y value, but what's different about this one down here is you have the same x value or input mapping onto different y values. Okay, the definition of a function, if we go back to the note sheet, is that each input goes exactly to one output. So we need to make sure those x values, again, are associated with only one y value. And we're looking to see if our inputs or our x values really just have that one. So there's a little repetition here in your notes, but I want to make sure that that definition clearly gets in your notebook, and then we're going to work with it in some of our examples. So as you can see, what we have for the first example, instead of a little blob of x and y values, or instead of a little machine, we've got a set of points, okay? So remember, each point has an x and a y value. We have an x and a y value here in our second point, and we have an x and y value on our third point. This is an example of a function, and the reason it's a function is because each x value, 3 maps onto 3, 4 maps into -1, and 2 maps onto 3. Each x value just has one y value mapped to it. This one over here is an example that is not a function. And the reasoning is, when you look carefully at this point and this point, they each have the x value of 1. And in this example, 1 is mapped onto the 8, but it's also mapped onto a -3. So it is not a function because the 1, or let's call it the input 1, is paired with 2 different outputs. And that's not allowed with a function. So remember, it's exactly one y value for each x value. So at the bottom, we have some examples where there is a table of values. Sometimes we get a table of values, and we need to look at that carefully to see if we do have a function. So again, we're looking to see if each x value basically is repeated, and then there's different y values with it. In this case, we have way different x values. There's no repeats, so yes, this is a function. Every x has exactly one y value. But over here, even though the table is listed horizontally, we see that we have an x value of 3. And over here, the 3 is mapped onto a -6. And down here, the 3 is mapped onto a 5. So this is not a function because 3 is paired with different y values. So again, inputs are your x's, outputs are your y's. Lastly, we're going to take a look at some graphs. If you see that a graph represents a function, there's another way to tell if it's a function besides focusing on the individual points. It's kind of nice. It's called the vertical line test. And basically what you do is you either draw a vertical line, or I usually use my pen, and what you'll do is you'll look at the graph and you'll see if that vertical line intersects your graph more than one time. If it intersects at exactly 1 point at all times, then we do have a function. So in the beginning of our examples down here, we have this little curvy kind of roller coaster looking graph, and I can take my pen and I can draw a vertical line on top of my graph, or I could just hold the pen across. And what you're seeing is that it only intersects the graph in 1 point when I hold or draw my vertical line there. I could draw my vertical line here and it intersects once. I could even draw it here at the top where this little hill is on the roller coaster graph. And no matter how many times I try to draw my vertical line, I only intersect the graph at 1 point. So that's how I know this is a function. Now the middle graph, you can see, is kind of curved the opposite way. So at the very beginning, I can tell that it's going to intersect in more than one place if I draw a vertical line here. It'll even intersect multiple places if I draw the vertical line on the other side. So really, we just have to show that it intersects more than once, and then we know it is not a function. This is because this x value would have multiple y values, and that's what we were looking for on the other side of the notes when we had a list of ordered pairs, or if we had a table, we saw that multiple y value matched with the x's. So here we have a straight line or a linear function, and again, when we use our vertical line test, you can draw a bunch of vertical lines, or you could just take your pen and go across and see that it's only going to intersect exactly once, and that means we do have a function. So here's the important part of this right here. And then we've got a couple more examples down at the bottom. If you hold your vertical line across, or if we draw it across, we can see this intersects more than once. So that means we have an example that is not a function. And then a lot of kids think that this one is the same case because it's similar to the graph that we had over here. But when this is rotated and pointing upwards or downwards, you can see that that vertical line is still crossing exactly 1 point. So this one is a function. And it's a function when you turn that curve upside down. It's called a quadratic function. You'll be studying them a lot more next year. So I've just got a couple more examples to share with you. And the images I found should be down here. So let's see, we've got a couple examples here. And the first one we said is a function. You've got this vertical line. It only intersects once. A linear function is a function. And this one is not. You can see that that curve kind of comes back on itself, and you've got 3 intersections right here. So we have an example that's not a function with our vertical line test. There's another one that's not a function. If you see this notation, don't be surprised, because that is what you will use in high school when you work with functions. This year, mainly we stick with x and y, but you might see the f of x. And then, of course, we've got a couple examples here. This is showing the vertical line drawn on this line, so yes, it's a function. This one is not. You'd have to draw the vertical line right here to see the two intersection points, so that's why it's not a function. And of course, this one is not a function because of this point right here. And at the very end here, I just wanted you to practice a couple where you would be able to look and see. Do you believe these are functions? Do you believe you have one function? What do you think about these last three? If you said this one is a function, you were correct. No matter where I draw my vertical line, I'm going to have one intersection point. So yes, this is a function. And it turns out this is a function over here too, because I can draw my vertical line here, 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 or here. But the one that was not a function is right here in the center, okay? This curves back on itself, so if I draw my vertical line right here, I have more than one intersection point, so it is not a function.